Think about one of the most complex places on Earth, a modern factory. Well, right now, a quiet revolution is taking place inside them. There's a technology called the digital twin, and it's basically giving these industrial giants a virtual brain. And trust me, it's changing everything. Let's dive in.
But first, let me start with a question for you. What if a factory, with all its thousands of moving parts, could actually see a breakdown coming and fix the problem before it ever happened? I know, it sounds a little like science fiction, but that's the core promise of the technology we're talking about today.
So, to really get why this is such a game changer, we first need to understand the immense pressure that today's factories are under. They're at a breaking point.
I mean, we're not exaggerating when we say that manufacturing is facing a crisis of complexity. You've got customers who want everything customized, products that are more advanced than ever before, and a constant flood of new technologies. It all creates this super uncertain environment where factories have to be unbelievably fast and flexible just to stay in the game.
And here's the real problem. The old ways of doing things, the old planning models, they just can't keep up. They're slow, and most importantly, they are reactive. They're based on old data and what you thought would happen. So the moment something random hits, a machine suddenly fails, a supplier is late with materials, you name it, the entire system just grinds to a halt while everyone scrambles to figure out what to do next.
So how in the world do you manage that kind of real-time chaos? Well, it turns out you build a perfect virtual copy of the chaos itself. It's time to meet the digital twin.
So what is a digital twin? At its heart, it's a perfect virtual replica of something in the physical world. It could be a single machine, a whole production line, or even the entire factory. But here's the key part. It is not a static 3D model. It is constantly being fed live data from sensors on its real-world counterpart. So the virtual version is always, second by second, a perfect mirror of what's happening in reality.
And this is a fantastic way to think about it. It's like a doctor who has a perfect virtual clone of a patient. They can test a dozen different treatments, run endless simulations, and see the results instantly, all without any risk to the actual person. In our case, that patient is a multi-million-dollar factory floor. You can play God in the virtual world to perfect the real one.
But having a perfect mirror is really only half the story. The real magic, the true power, comes when you give that mirror a brain.
And this is where you can really see the massive leap we're talking about. Look at this comparison. The old traditional methods, they used historical data to tell you what happened. A digital twin combined with AI uses live, real-time data to tell you what is happening right now and, even better, to predict what is about to happen. It literally turns that mirror into a crystal ball.
So, how does it all fit together? It's all about this constant, non-stop feedback loop. Step 1, sensors out on the factory floor are gathering tons of live data. Step 2, that data instantly updates the virtual model. Step 3, this is where the AI brain kicks in, analyzing all that data, simulating thousands of future possibilities to spot problems or find opportunities. And finally, Step 4, the system shoots recommendations back to the real world to make things run better. It's this cycle, sense, analyze, act, repeat, that's so incredibly powerful.
Okay, so that's the theory, but what does this actually look like on the ground? How does this virtual brain really help run a factory? Let's take a look. Well, the powers it unlocks are pretty incredible. You've got predictive maintenance, which means the system can spot that a machine is about to break and schedule a repair before it ever goes down. Think of the downtime that saves. Then there's dynamic scheduling, so if there's a hiccup, the factory can instantly reroute jobs on the fly. And with real-time asset tracking, you know exactly where every single tool and part is all the time. And this isn't just a concept. We're seeing this play out in really specific high-tech industries. Let's take semiconductor manufacturing. By simulating that super complex wire bonding process, companies can catch design flaws way early. Or asset tracking. Research shows that using AI with Wi-Fi localization can improve shop floor efficiency with stunning accuracy. These are just a couple of ways this technology is solving real-world headaches. And here's the proof in the pudding, right? Just look at the impact this has on time to market. The difference between the old way of designing and using a digital twin is huge. By simulating the design of these complex semiconductor packages, companies get their products out the door so much faster. Being able to test and fail in a virtual space saves a massive amount of time and money. So, what does this all add up to? The bottom line is real, tangible results that businesses care about. We're talking less machine downtime, much higher product quality, because you've already ironed out all the kinks virtually. And you can give customers faster, more accurate quotes because the AI can predict exactly how long something will take to make based on the factory's live conditions.
Okay, so if this technology is so amazing, you're probably wondering, why doesn't every single factory on the planet have one? Let's talk about the real-world barriers, and then we'll look at what's coming just over the horizon.
And that's a fair question, because there are some pretty big hurdles to clear. The initial cost to implement all of this is, as you can imagine, a major factor. Then there's the sheer complexity of trying to get this new tech to talk to all the older systems already in place. And beyond that, you've got serious security concerns, and a big one, a shortage of skilled people who actually know how to build and run these things.
Let's zoom in on that security piece for a second, because it's a really big one. That constant stream of data flowing between the real factory and its virtual twin, that's a huge target for cyber attacks. To fight back, researchers are developing some really cool automated security systems that use AI to basically watch the data flow, detect anything that looks weird in real time, and shut down a threat before it can do any damage.
But despite those challenges, the future here is, well, it's incredibly exciting. The next big step is what's being called a system of systems. So imagine not just a twin of one factory, but individual twins for your suppliers, for the shipping networks, for the warehouses, all of them, linked together. You'd have a single intelligent network with a complete live view of the entire supply chain.
And if we look even further down the road, things get wilder. We're talking about integrating AGI, that's artificial general intelligence, into these twins, which would make their decision-making capabilities just unbelievably sophisticated. At the same time, we're seeing the beginning of a manufacturing metaverse, an immersive virtual space where new workers can be trained safely on dangerous machines, and engineers from opposite sides of the world can meet up inside a virtual factory to collaborate.
Which, of course, brings us to the big, final question. This technology is undeniably powerful. It's a fundamental change in how we make things. But as our factories get this incredible, intelligent virtual brain, what does that ultimately mean for the human heart of manufacturing? That's something we'll all need to think about.